This question is a 2013 combined science physics and it's question 11. So in this question that I want to highlight, you're given a component that you are not familiar with. So in this case, okay, this is a thermistor, which is only learned in pure physics, but nonetheless I say it can still come up for combined science as long as they give you the information. So this is actually a thermistor. All right, so the relation is like a sensor. It changes with temperature. So it's given here already. The resistance of X, okay, changes with temperature and is connected in series with a fixed resistor of 1 kilo ohms, which is 1000 ohms, and you have a 12 volt battery. So the graph given to you here is actually for the thermistor, okay, X, and this is the relationship. As you can see, as the temperature increases, the resistance will decrease. So this is that's the behavior of a thermistor. Alright, so the first thing that they ask you is for a temperature of 30 degree. So use figure 11.2. So when they state that, you have to actually show them on the graph clearly using a dotted line. So when the temperature is 30 degrees, so you draw a dotted line when it touches the curve, then you draw the dotted horizontal line, and the resistance of X when the temperature is 30 degrees Celsius will be 800 ohms. Next, okay, you are required to calculate the current in the circuit. So you already know that this is 800 ohms and they're connected in series. So the first thing you need to do is to find the total resistance Re, which is your 1000 plus the 800 for X, which is 1008 ohms. Then using your V equals to IR, the EMF is 12 volt, the current is what you want to find, and the total resistance is 1008. So you get 0.00667, and you can round off to 0.067A. Then for part 3 here, calculate the potential difference across Y, okay, and you know that this connected in series, the current flowing through X and Y will be the same. So if that's the case, very simple, your V equals to IR, and the given you have found that the current is 0.0667 times the total resistance 1000, so you get 6.67, and likewise round off to 6.7 volt. So that's how you solve for A. Next, for part B is explanation. So it's only given that as the temperature rises, state and explain what happens to the current in the circuit. So all these are quite straightforward, just using your basic. So for part 1, okay, as the temperature increases or rises, the resistance of X, okay, I'm writing in short form, so do remember to write in full. As the resistance of X decreases, the total effective resistance of the whole circuit will also decrease, because if this one drops, the total effective resistance is just the sum of both. And if that's the case, using V equals to IR, so since the V is the same, all right, and your total resistance decreases, therefore your current increases. So that is for the first part. And for part 2, they ask you what will happen to the potential difference across Y here. Now it's very simple, because you already established that the current flowing through the circuit, okay, or through X and Y will increase. So you just need to use, all right. So as current increases, that's from part 1, all right. So the current in your Y will increase. And using V equals to IR, that means V, the potential difference for Y, the current through Y, and the resistance of Y. So, but this RY is fixed, okay, it's constant, or you can say that's constant. Therefore, when the current increases, your potential difference across Y will increase. So that's very straightforward also. Now for the last part, part 3 here, they ask you the potential difference across X. Now this is where I need to bring your attention to. So if you were to think that using the same logic as part 2, I can say that the Vx equals to the current of X and the resistance of X. Now, if you were to use this, you'll find that you can't really explain. Now, why is it so? You already say that the current for the whole circuit is going to be higher. So likewise for the current through X and the resistance. Because the temperature rises, the resistance of X will be decreasing. If that's the case, one is increasing, one is decreasing, there's no way you can convince the marker what will happen to your Vx. So instead, I want you to use the concept that X and Y, they are connected in series. Alright, so if it's in series, the sum of Vx plus Vy will be equals to your 12 volt, the EMF for this case. Since you from part 2, alright, you already explained that the Vy increases. So if this were to increase and the EMF is still 12, that means to say therefore your Vx will, the potential difference across X will decrease. Now, I need to understand that even if this question do not give you part 2, you definitely have to explain this part and then conclude that the potential difference across X will decrease. So this is the way to tackle this question. Alright, so take note of this part here. You cannot use V equals to IR to directly explain because none are constant, so both are, one is increasing, one is decreasing, so you cannot convince whether Vx will increase or decrease. So you have to use the concept that the fact that they are both in series. For the last part, part C, is rather straightforward. It's just basically the function of the fields and how it works. So I will not go through in this video, so just refer to your notes. Alright, thank you.